Hi, welcome to our next level 3 critical path analysis video. Right, we're getting straight into example 2. This is from our last video, and we have a precedence table and our network diagram. Now remember, we try and find all options to get from activity A to activity H, and it's the option that is the greatest time that becomes our critical path. And this is the minimum time to complete the project. Right, well, what we're going to do now is look at these empty boxes in each of the nodes. We'll put the critical path aside for a sec and let's talk about these boxes. The top left is going to represent our earliest start time for the activity. The top right is the earliest finish time for each activity. The bottom left is the latest start time for each activity. And the bottom right is going to be our latest finish time for each of the activities. Right, we're going to start with the forward run, which is the earliest and start and finish times. Right, well, let's start at activity A. It starts with the earliest time of 0, which is the beginning of the project. It takes 1 minute to complete, so A will finish at the earliest of 1 minute. Right, we move on to activity B. Notice activity A finishes earliest at 1 minute, so activity B starts at 1 minute, takes 2 minutes to complete, and it will finish at 3 minutes. We move on, we're moving down the critical path, by the way, first. I want to make that clear. We do the critical path first. So we're moving on to activity D next, which is in the critical path. Now notice B finishes at 3 minutes, so D can start at 3 minutes, and it takes 3 minutes to do, so it will finish at 6 minutes. So then we're moving on to activity F. Notice that activity D finishes at 6 minutes, so activity F can start at 6, it takes 2 minutes to finish, and it will finish at 8 minutes. And finally we go to activity H. Notice that F finishes at 8 minutes, so H can start at 8 minutes, and it takes 3 minutes to finish, which will finish at 11 minutes. Now let's go to the ones we're not on the critical path, so let's go to activity C. Now, activity C has to follow from activity A, and activity A finishes after 1 minute. So activity C can start at 1 minute, and it takes 2 minutes to finish. So the earliest time it will finish is 3 minutes. Activity E is next, and it must follow activity B. Activity B finishes at 3 minutes. So activity E can start at 3 minutes. It takes 3 minutes to do that activity. So the earliest time it will finish is 6 minutes. And activity G follows activity E. Activity E finishes at 6 minutes. So activity G can start at 6 minutes. It takes 1 minute to complete, and it can finish at 7 minutes at the earliest. Right, that's our forward run done. So let's now go and do our backward run. This is the latest start times and latest finish times. Again, we're going to follow the critical path, but we're going to work backwards. So let's work with activity H. And notice along the critical path, we must have the same earliest start times and earliest finish times and latest start times and latest finish times. That's because the critical path must be done at those exact times. We can't delay any of them. But let's look at the other activities now. Activity G. Now notice that must come before activity H. In activity H, the latest start time is 8 minutes, so the latest finish time for activity G is 8 minutes, and it only takes a minute to finish, so the latest start time is 7 minutes. When we go back to activity E, notice that the latest start time for activity G is 7 minutes, so the latest finish time for E is also 7 minutes, and because it takes 3 minutes to finish, the latest start time for E is 4 minutes. And finally C, notice the latest start time for F is 6 minutes, so the latest finish time for C is 6 minutes. Because it takes 2 minutes to complete, the latest start time for C is going to be 4 minutes. Right, that's our forward and backward run done. In the next video, we're going to chat about what these numbers mean. So thanks very much for watching.